girls, it's Mrs. Szili here. For those of you who don't know me, I teach second grade at the Scott Elementary Building. I'm really excited to share our lesson today, which is on fractions. So the first thing I want to do is tell you what a fraction is. Fractions are equal shares of a whole. Now this word is really important, equal, okay? Because when we do fractional parts of something, each part has to be an equal amount, an equal share, okay? Now, a fraction has two parts, and it's broken down by this line that's in the middle, okay? There's gonna be a number on the top and a number on the bottom. Now, these are kind of really big words, but I like to share them with second graders because you're gonna hear them eventually over time. The top number is called the numerator, and the bottom number is called the denominator. Now, here's a fun way to remember the two names. The numerator is on the top. It starts with the letter N, and when you think of a compass, the top part is north, so I think numerator north. That's my way that I think about that, okay? The denominator is on the bottom, right, or down. Denominator starts with the D, just like down, so it's a good way to think about it. Now again, those words aren't really words you need to know right now, but they're good things to kind of store in your brain for maybe next year and the years to come, okay? Now the numerator, or the number that's on the top, is gonna be the share that you're talking about, okay? Now we'll get into this and I'll explain it a little bit more, but that's like whatever piece I'm talking about is gonna be what's on the top, the numerator. The denominator, or the number on the bottom, that's gonna be how many total shares there are. So how many pieces the shape is cut into, that's gonna always be the number that's on the bottom, or the denominator, okay? Now let me give you an example so you can really see what I'm talking about. I have a circle here, and I have one line in the middle. I have it broken down into two pieces. That's the total number of shares that we have. So that's why that number is on the bottom. If I was just talking about one of those pieces, I would have the fraction 1 over 2. And I'm sure many of you already know what that one is. This is actually called 1/2. Okay, now let's pretend we're all together for right now. How many people have heard of a half? Raise your hand. Okay, and I know many of you probably have. I'm sure some of you have said, hey, I have a sandwich. I'm gonna cut it in half and I'll share it with you. You get a piece and I get a piece, right? So when we cut it in half, we end up having two pieces of the whole. But when you're only talking about one of those pieces, you call it 1/2, okay? So that's our first example. Now I'm gonna show you some other examples too, not just with this circle. I'm gonna do some erasing really quick, because I wanna show you how you could do fractional parts, not just of a circle. Now, last week, Miss Goloszewski did a lot of different shapes with you. So I'm gonna show you a couple shapes and kind of how we can break them down into some separate pieces, okay? All right. So we just did a half and what that looks like. I wanna also show you what that would look like in a square, okay? So in a circle, it would look like this, okay? This would be 1/2, and this piece would also be 1/2. Now if I were to do it in a square, okay, it could look a couple ways. It could look like this, right? Maybe it could look like this. That would also be 1/2, okay? Another fraction I want to talk to you about is called 1/3. 1/3. Now, whenever we're doing fractions, obviously not when it's 1 over 2, but when we're doing fractions, we use number words like the grade that you're in, okay? So 1/3, like 3rd grade, okay? 1/3 might look like this in a circle. And the reason it would look like that is because this is one piece. And how many total pieces? 3. So that would be 1/3, that would be 1/3, and that would be 1/3, okay? Another fraction I wanna talk to you about is fourths. So let's pretend we're together for a second. If I were to have fourths, how many total pieces would be in the shape? there would be 4 total pieces. So let's do a square. It might look like this. How many pieces are there? 1, 2, 3, 4. And if I'm talking about just one of the pieces, it would be 1 over 4 or 1/4, okay? Now I could go on and on and on. I could do fifths and sixths and sevenths and eighths, and we will see a little bit of those. But the main ones we're gonna focus on is 1 over 2, otherwise known as a half, 1 over 3, which is otherwise known as a third, and a fourth, okay? I'm gonna leave those up. The next thing I'm gonna do is show you some shapes, okay? I think I'm gonna start with my triangle. I'm gonna show you some shapes, and I'm gonna ask you, yes or no, if you guys think that the shape has equal shares. And then we'll also talk about what the shares actually are called, okay? So I know we're not together, and I know it sounds weird for you to shout out answers at your computer or at your phone or your iPad or whatever you're doing your lesson from, but do it. Just let's pretend we're together just because, you know, we haven't been in so long, okay? So what I want you to say out loud is either yes or no if you think the shape is broken up into equal shares, okay? So let's start with this. What do you think? Yes? Are they equal shares or no? If you said yes, you're correct, okay? Now let's talk about what the fractions of the shapes would actually be. Well, it's broken up into 2 pieces. So since it's broken up into 2 pieces, the bottom number, or the denominator, would be a 2, right? And they're each 1 piece. So take a look. It would be each 1/2 of the triangle, okay? Now I want to show you something really cool too. If I were to take this shape, and I want to really know if it's 2 equal pieces, if I fold the shape, it should overlap itself completely. You see how that happens? Completely overlaps. So that's a really great way in your head when you see a picture of a shape and it's cut in a certain way, if you want to try to decide, okay, are they 2 equal pieces? Well, can they overlap each other and still look the same? Then yeah, they are. So yes is our answer to that one. And they're each a half, okay? I'm going to show you another triangle. Okay, so again, shout it out. Yes or no, are these equal shares? If you said no, you're correct. And here's why. If I were to cut this, okay, let's pretend I have 2 friends and my 2 friends are like, I want to split that and I want to have half and I want you to have half. And we try to split it between ourselves. If I were to cut it right there and give one person this piece and one person this piece, one person would be pretty upset because they'd be getting the smaller piece, right? That means the shares aren't equal. So in this case, I'm not even going to write a fraction on this triangle because it's not broken up into equal shares. Okay, so there's no fractions for this one. All right, those are my triangles. Let's jump into circles, okay? Now, again, when I show you the shape and I show you the fractional parts, I want you to say yes or no. Yes, it's equal shares, and no, it's not, okay? You decide. What do you think about this one, this circle? Do you think it is broken up into equal shares? Yes or no? The answer is yes, it is. And if I were to cut this just like this, I bet you it would all overlap each other and the pieces would be exactly the same. Now, let's think about the fraction. Okay, how many pieces are there? 1, 2, 3. So that's going to be our denominator, or our number on the bottom. And then each one is 1 piece. So they're each called 1/3. Okay, good job. All right, let's look at another circle. Remember, say yes or no. Is it broken down into equal shares? If you said yes, you are correct. Okay, now let's think about what's the fraction of this one. What would each of these pieces be called? Think about how many pieces there are, and that's going to help you to get that denominator, their number on the bottom. So since there are a total of 4 pieces, these are going to be broken up into fourths, okay? And that looks like this. 1/4, 1/4, 1/4, and 1/4. good job. Let me show you another circle. This one's easy, but I still gotta give it to you. What do you think? Yes, equal shares, or no, not equal shares? If you said yes, you are correct. Absolutely, absolutely equal shares. They're two pieces that look exactly the same, right? Since there's two pieces, and look, I even have that up here already, so as a little hint. These would be called 1/2, otherwise known as 1/2. Okay, these would be called halves. All right, good job. All right, this is my last circle. Do you think this one is broken up into equal shares? So give me a shout out, yes or no. If you said no, you're absolutely correct. Now let's talk about why, okay? To me, it does look like they're similar in size, but look at the ends, okay? Look how tiny that piece is in comparison to as the circle broadens or gets wider, okay? So whoever got this piece wouldn't be all that happy, right? Their piece would be a lot smaller. So since the answer is no, I'm not even gonna put any fractions on that one, okay? All right, now we're gonna do some rectangles, okay? All right, so here's a rectangle. Now remember, a rectangle has two long sides and two short sides. So this is a rectangle. Would you say yes, it's equal shares, or no? The answer is yes, definitely equal shares. Now, I know this looks a lot different than this one, right? Because they're two totally different shapes. But aren't they still broken up into halves? And the answer is yes, because it's two equal pieces. So this, even though it's a totally different shape, is still broken up into halves, okay? So for this one, I'm gonna do the same thing. The denominator is 2, since there's two pieces, and then a 1 on top of each one, since it's one of those pieces. So it looks like that, okay? All right, let's look at another rectangle. This is a really big one. And I really wanted to show you that it doesn't matter the size of the shape, but that you can still break them up into equal or not equal pieces. So how about this one? Would you say this is broken up into equal shares? If you said yes, you're correct. Okay, now let's talk about how many pieces they are, okay? So it has 1, 2, 3 pieces. So since it has 3 pieces, our denominator is going to be 3. And remember, our top number is each piece. So this is 1/3, this is 1/3, and this is 1/3. I'm gonna talk to you about how we combine those in a little bit too, okay? All right, you guys are doing awesome. I'm really pretending like I could hear you saying the answers, by the way, because I miss it so very much. All right, let's look at this rectangle. Would you say this rectangle is broken up into equal pieces? If you said yes, you are correct. Good. So let's look at how many pieces it has. Okay. Now remember, a rectangle can look like this or like this. Either way, if you look at it, there's how many pieces? 1, 2, 3, 4. So this is broken up into fourths. Okay. And let's remember how we write that. Remember, the denominator is the bottom number. That's the one that tells us how many pieces there are total. So this would be 1/4. This would be 1/4. 1/4, and 1/4, okay? Now I want to show you something really quick, and I have to come off camera just so I can grab my scissors. But I wanted to make sure I showed you, and back, how to prove that this shape is broken up into fourths. I'm actually gonna cut those lines, okay? So when I do that, and now my lines are definitely not perfect, but I promise you these are gonna look really similar. And when I do this, all these little pieces should be the same size. I should be able to overlap them and then be the same. Am I able to do that? The answer is yes. So that's how I can tell that these are all equal in shares. They're all 1/4 of that rectangle. Now, you know what? Let me go back really quick. Remember this triangle that we said no to? Watch what happens when I cut that one. Can you overlap them in any way to show that they're equal shares? You can't. And I know for the most part, this one seems pretty easy. Some people are like, oh yeah, of course that's not equal, but not just not equal, they're not the same size or shape or anything, okay? So sometimes people need to visually see that to know they're not equal shares. Okay, we're still on rectangles, right? I have a couple more. How about this one? Would you say that this rectangle is broken into equal shares? Yes or no? If you said no, you're correct. It's broken up into 4 pieces, but are those 4 pieces equal? No. Look how tiny this is, right? And I was really kind of sloppy with my lines on this one, but still, these are all different shapes, widths, everything. So this is not broken up into equal shares, okay? All right, how about this one? And it doesn't matter which way I hold it, right? If you said, yes, you are correct. Now I want to show you something. So I have another rectangle, it looks just, it's broken up into the same fraction. This is broken up into halves and so is this. Do they look the same? No. But the shapes themselves are totally different sizes. So of course the halves are going to look different too. But not just that, I can make a rectangle be cut in half going this way or going up and down. So rectangles can be cut into halves in 2 different ways, okay? So I'm gonna put my fraction on here. So this would be 1/2, otherwise known as 1/2. Okay. All right. This is my last rectangle, and then we'll move on to squares. Okay. What do you think? Yes or no? If you said yes, you are correct. Very good. So how many pieces does this have? 1, 2, 3, 4. Just like that one I cut apart, except this one has the lines going this way. So I just really wanted to show you that 4ths can look like this, or 4ths can go the long way, okay? So since it's broken up into 4 pieces, each one would be 1/4. It'll look like that. Each of those pieces would be 1/4. Great. Okay, now we're gonna move on to squares. Alrighty. We're gonna move a little quicker through the squares. Yes or no? If you said yes, you are correct. This would be 1/, how many pieces? 2. So this would be 1/2. Now look, 1/2 in a square looks different than 1/2 in a circle because they're different shapes. But are they still broken up into 2 equal shares? The answer is yes. All right, here is another square. Oh, I didn't write on the back of that one. Yes or no? Equal shares? If you said yes, you are correct. Now how many pieces are there? 1, 2. So guess what? This square is broken up into halves, and so is this one. So a square can have a line going down, it can go diagonal to show halves. The pieces are still equal, okay? These 2 pieces are equal to each other. These 2 pieces are equal to each other. So we're still showing equal shares, even though they look a little bit different, okay? I just want to be clear on that. All right. Here is our next one. Would you say yes, equal shares, or no? And a lot of times when I think about equal shares, I like to think, if I had friends to share this all with and each friend got a piece, would they all be happy? Would they all be happy with the size of their share? And if you said, yes, you are correct. Yeah, there's 4 total pieces, so that's the bottom number of our denominator. These would be, and look, have it right there, right? These would be all 1/4 of the square. 1/4. Okay? Okay, how about this one? Yes or no, equal shares. If you said yes, you are correct. Now how many pieces are in the square? 1, 2, 3, 4. That's interesting because we just had 4. But how different do these look? very different, but aren't they still equal shares? And the answer is yes, because in this square, we're just separating it in a different way, okay? So these are still called fourths. It just looks a whole lot different than this one, but it's still an equal share of the square. So they're all still fourths. And how about this? One more way I can show fourths. I kind of gave you the answer that this, yes, is equal shares, right? But I just really wanted to show you that fourths can be shown like a window. Fourths can be shown with the lines drawn up or sideways, or you can show fourths like an X. And this is specifically in a square. And the reason for that is because a square has 4 equal sides, so it makes it a lot easier to make those fourths, okay? All right, I have 2 left. How about this one? Equal shares? Definitely not. Would my friend be happy with a share that looks like that in comparison to like that? Of course not, okay? So you can tell that those pieces are not equal. All right, here's my last one, kind of a challenge. What do you think? Do you think this square is broken up into equal shares? If you said yes, you're correct. Now, how many pieces? 1, 2, 3, 4, 5, 6, 7, 8 pieces. So we didn't talk about that anywhere here, but we could do this. The number on the bottom, remember, is going to be how many pieces there are. If there's 8 pieces, the bottom number is 8, and each one of those pieces would be called 1, and now remember, it's like your grade, 1/8, 1/8, okay? Pretty cool, right? And I kind of was able to make this by putting an X and then a window, okay? So I kind of broke down the fourths into another smaller piece, okay? All right, awesome. All right, the next thing that we're gonna do is I'm gonna show you how, if I draw a shape and I shade a shape in, just a part of it or a fractional part of it, how much is actually shaded, okay? Because that's another important thing. I'm gonna hold my paper just so I remember what shapes I wanna do with you. Okay, let's do a really super simple one first, okay? Here's a circle. I'm gonna shade this side. So the question is, how much is shaded, okay? Here's what I think to myself. These are the questions I ask when I wanna know how much is shaded. The first question is, well, how many parts are shaded? And the answer would be 1, right? So since 1 part is shaded, that's gonna be our top number. Over, now remember what the denominator is, the bottom number is always how many parts are there in all? 2. So how much is shaded? 1/2, okay? Let's look at another shape. So here's a square, and I have this shaded. Okay, question 1. How many pieces are shaded? 1. Over, how many total pieces are there? 1, 2, 3, 4. So 1/4 of the square is shaded. Okay, how about this one? Just pretend it's shaded. Oh, okay. Okay, how many pieces are shaded? 2. Over, how many pieces are there in all? 2. So guess what? This whole triangle is shaded, okay? Whenever you have the same number on top and bottom, that's representing the whole entire thing, okay? That was a little bit tricky. All right, how about this one? Here's a rectangle. And I have that. So how many pieces are shaded? 1, 2, so that's my top number. Over, how many total pieces are there? 1, 2, 3. So 2/3 would be shaded, okay? Okay, how many pieces are shaded? 2. Over, how many many total pieces are there? 1, 2, 3, 4. So 2/4 of the square is shaded. Okay, good. All right, now I'm gonna do just a couple more of how much is shaded, but this time instead of doing shapes, I'm gonna show you, there's still gonna be shapes, but I'm gonna do it a little bit differently, and I'll explain in a second. So let's say I drew some circles, and I shaded a couple of them. And I said to you, well, what's the fractional part of this shaded circles? Well, it's the same thing. How many pieces are shaded? 3, right? Over how many total circles are there? 1, 2, 3, 4. So my answer would be, well, 3/4 of the circles are shaded, right? So even though these are separate pieces, we're still able to talk about the fractional part of how much is shaded amongst all of them, okay? How about this one? That's a bad one. Ooh, okay. All right, so how many are shaded? 4. Over how many total squares are there? 1, 2, 3, 4, 5, 6. So the answer would be 4/6. Remember 6th grade? Sixths. 4/6 are shaded. 4/6 of the squares are shaded, okay? All right, I'm gonna do one more with you. And this one is kind of like the square that I showed you a second ago. Okay. Kind of looks like a pizza. How much is shaded? Well, there's one piece shaded over how many total pieces? 1, 2, 3, 4, 5, 6, 7, 8. So 1/8 is shaded, okay? Now I can keep going around and shade, right? How much is shaded now? Well, the only part that has to change is this one, because this doesn't change. Still have 8 pieces, right? So 2/8 are shaded. How many are shaded now? 3/8, right? 3/8. And we can go round and round and round and round until you get to 8/8, and that would be the whole thing, okay? All right. That's fractions, okay? You're gonna have a bunch of stuff to do in our slideshow this week on how much is shaded and how much is not shaded, and just keeping in mind and remembering that fractions are equal shares. So whenever something is shaded in, you wanna make sure it's an equal piece. But before I wrap up the lesson, I did wanna give you an optional challenge. And I think it's gonna be fun. It is not gonna be something you have to do, but I would like to see you try it, okay? Even if you try it with somebody at home and maybe they help you out a little bit. So the challenge is gonna be about muffins, okay? And I want to pretend, now this is not the challenge question, I'm gonna do an example challenge question first, so I can solve it for you, so you can see kind of what I'm looking for, and then I'll give you your actual challenge question, okay? So I wanna share some muffins with my friends. I wanna share 2 muffins, and I'm just gonna draw 2 circles, because I am not a good drawer, but I can draw circles. So I have 2 muffins, but here's the problem. I have 3 friends. So the question for us in our challenge is, how can I share these 2 muffins with my 3 friends, okay? Friend A, B, and C, let's call them, just so we have a way of kind of differentiating between them. How can I share these muffins with 3 friends? I only have 2 muffins. Well, we know that we can make these muffins into some fractions. So let me show you a way that you'd be able to share these 2 muffins with your 3 friends, okay? What if I broke these 2 muffins into thirds, or 3 equal shares? Watch. And what if I gave my first friend A, this piece, friend B this piece, and friend C this piece? And what if I did the same thing on the other one? Friend A, B, and C each get one of those pieces. So let's talk now about how much each kid got. Did they each get an equal share? Oh, yes, they definitely did. But how much did they get? That's the other question I want to know. We split it. Everybody got an equal piece. My next question is, how much did they get? Okay, well, let's look at friend A. How many pieces did they get? Well, one here and one here, right? So if they got one here and they got one here, that's a total of 2, right? 2 pieces, okay? But it's still 1 and 1. We're gonna make 2 separate fractions. Over, how much did they get out of this? 1 out of how many? 1, 2, 3. 1/3 and 1/3, okay? So they ended up getting, if you add that together, they got 2/3 of the muffins. And that's the same for everybody. Okay, so that's our challenge. Now, I did a challenge example. I'm gonna give you a new challenge, okay? So here's your challenge. And I will be posting this optional challenge. I'm gonna post it for you as a separate quiz for this upcoming week. It's optional, you do not have to do it. If you choose to do it, awesome. If you choose not to do it, that's fine too. So here's your challenge. We're going to have 3 muffins. But we have 4 friends. So your first question is, how can you share these 3 muffins with your 4 friends so that they each get an equal size piece? That's your first question. Okay, I'm gonna repeat that again. How can you share these 3 muffins with your 4 friends so they each get an equal size piece? The second question is, once you figure out how to do that, how much did they each get? What's the fractional part that they each got? Okay? Now remember, you have 4 friends, so if you want to use the letters A, B, C, and D to help you, you can. You can draw it on a piece of paper. You can just then put your answer onto our little quiz, and I'm going to make sure to share with you guys. Remember, this is optional. It's an optional challenge. But give it a go. Give it a try. The worst thing that happens is you don't get it, and then you can contact me and I can help you through it, okay? I will be sharing the answer at the end of the week in another little video, and I will say that there are multiple options of how you can split these 3 muffins to share amongst your 4 friends, okay? So I don't want you to think if you decide to talk to a friend about this in 2nd grade, if you decide and you say, hey, how did you do? Did you get the answer to Mrs. Szili's challenge question? And if they did it differently than you, it's okay. There's a few ways that you can do it, okay? So good luck on the challenge. Remember, that's gonna be posted separately as a separate optional quiz for this week, in addition to the quiz that we always post for you to turn into your teachers. But the challenge will also be shared with you as well. Again, optional. Give it a try if you want to. It should be fun. If anybody has any questions, make sure you get in touch with your teachers. I want to let you know how much we all miss you so very much. This has been a really hard time for all of us, but it's been nice to be able to communicate with all of you through Google Classroom, and we hope that you're learning a lot still, even though we're separated from one another. Good luck this week on all of your lessons. I hope you have a fantastic week, and good luck.